Dear students, I welcome you in this lecture from the chapter Linear Programming Problems. In this lecture, we are going to solve some examples on linear programming problems. Let us see an example of linear programming problem. Any linear programming problem has three parts. So first part is objective function. Here the example is to maximize the objective function z is equal to 10x plus 20y. This part is objective function. Objective function. Second part is that of linear constraints. So here we have two linear constraints or two linear inequalities. So this part is linear constraints and it consists of two inequalities. First inequality is 2x plus 3y is less equal to 18 and second inequality is 3x plus 3y is less equal to 21. Again, the third part is that of non-negativity constraints. So these are non-negativity constraints. Due to non-negativity constraints, the solution of linear programming problem is always in first quadrant. So while shading or determining feasible region, remember that we have to restrict ourselves for first quadrant only. The solution of LPP will not be in second, third or fourth quadrant due to non-negativity constraints. So here the problem is to maximize objective function z is equal to 10x plus 20y. The problem is of maximization. Subject to these linear constraints. These are two linear constraints. First is 2x plus 3y is less equal to 18 and second is 3x plus 2y is less equal to 21. We also have non-negativity constraints. X is greater equal to 0 and y is greater equal to 0. We are going to solve this linear programming problem by geometrical method. It involves certain steps. So first step is to plot the lines. First step is to plot the lines. First step in solving linear programming problem is plotting lines. So which lines we have to plot? We have to plot the lines corresponding to linear constraints only. The lines for non-negativity constraints are already plotted as they are x's. X is equal to 0 and y is equal to 0 are nothing but y and x axis respectively. So we need to plot two lines corresponding to two linear constraints. Note that it is impossible to plot this line. In fact, it is not equation of line. Z is equal to 10x plus 20y is not an equation of line. So we have to plot lines only for linear constraints and these lines are 2x plus 3y is equal to 18 and second constraint is 3x plus 3y is equal to 21, or second equation for which we have to plot the line is 3x plus 3y is equal to 21. In the very first lecture from this chapter, we have seen how to plot the lines. So, in order to plot the lines 2x plus 3y is equal to 18, we need 2 points, point on x-axis and point on y-axis. For this line 2x plus 3y is equal to 18, point on x-axis is given by 18 upon 2, c upon a, constant upon coefficient of x. This constant upon coefficient of x, 18 upon 2, which is equal to 9. So thus we get our first point 9 on x-axis. The point on y-axis is given by c upon b, that is constant upon coefficient of y. So constant is 18 and coefficient of y is 3. So 18 upon 3 is equal to 6. Here we get another point 6. And we obtain a line by joining these 2 points. Point 9 on x-axis and 0.6 on y-axis. So in the red color we are representing the line 2x plus 3y is equal to 18. The another line which we want to plot is 3x plus 3y is equal to 21. So 3x plus 3y is equal to 21. Point on x-axis is given by c upon a, that is 21 upon coefficient of x, which is 3. So we get a point 7 on x-axis. So thus we get another point 7. Point on y-axis is given by c upon b, so which is 21 upon 3, again it is equal to 7. So we get another point here 7. We draw a line joining these 2 points, point 7 on x-axis, point 7 on y-axis, and this line represents the equation 3x plus 3y is equal to 21. Thus, we have plotted lines. First step is completed, plotting lines. Now, in second step, we have to determine the feasible region. How we determine feasible region? We have seen it in earlier part of this chapter. I'll request you to go through both the parts before you watch this lecture. The first part was plotting lines and second part was determining feasible region. So you must go through these videos before you watch or study this lecture. Now, determining feasible region for linear constraints. Due to non-negativity constraints, our solution will always lie in first quadrant only. It will never be in second, third or fourth quadrant. Okay. So how we determine feasible region? For first constraint. So for first constraint, consider the first inequality. 2x plus 3y is less equal to 18. Check whether the origin satisfies this inequality or not. Origin means x has 0 coordinate and y has 0 coordinate. So 2 into 0 plus 3 into 0 is less equal to 18. 0 is less equal to 18. So this is true statement, isn't it? Because 0 is less equal to 18. So this is true statement, means inequality gets satisfied. Hence we say shade the origin side of this first constraint. And again we have to restrict ourselves in first quadrant due to non-negativity constraints. So what is origin side of this line? 2x plus 3y is less equal to 18. Remember, this line is given in red, represented in red color. So origin side, where the origin lies, here is the origin. So we are going to shade it, or say as a rough work, I'll put here right tick. Okay, so right tick I am putting over here. Okay, similarly we will find feasible region for second constraint. So if you go through second constraint is 3x plus 3y is less equal to 21. Again put x at 0 and y at 0. So this will come as 3 into 0 plus 3 into 0, that is 0 plus 0, which equals to 0. 0 is less equal to 21. So this is true, and again we have to shade origin side. Origin side means the side of that side of line which contains the origin. So green line is represented here, and its origin side I am going to put it say by cross. This time I'll be shading it through cross. In second step we have to determine common feasible region. Common feasible region means what? Where both ticks and cross are present. So here you can see this area cannot contribute to common region because it contains only cross but not ticks. Similarly, this region will also be not in the common region because it contains cross right ticks but not cross. Okay, so the only common feasible region is going to be this one, this where cross and ticks are present. Okay, so whatever we have shaded in white color, this part, whatever which we have shaded in white color is the common feasible region. So second step of the problem was to determine common feasible region, and we have determined it. So second step in solving linear programming problem is to determine common feasible region, and we have determined it here. Common feasible region we have determined. Now third step is to find vertices of common feasible region. So third step is to find vertices of common feasible region. Vertices of common feasible region. In order to find vertices of common feasible region, you see this is the common feasible region which we have identified in the previous step. So it will have four vertices. Say this is first point O, say this is point A, point B and point C. So we are having four vertices. What are coordinates of O? Origin has coordinate 0, 0. What are coordinates of point A? We have determined it while plotting lines. So it has coordinate 7, 0. What are coordinates of point C? While plotting the line, again we have determined that its coordinates are 0, 6. So 3 out of 4 vertices are already known. Now the only question is how to find B. So B is intersection point of these two lines, and we have seen how to find intersection point of two lines. If you have not gone through that video, I'll request you to go through that video and see how we find intersection point of two lines. Now what are the equations of two lines here? 2x plus 3y is equal to 18 and 3x plus 3y is equal to 21. So let us see how we are going to find vertices of vertices which is vertex which is the intersection point of two lines. Recall the equations of two lines. So here two lines are, first line is 2x plus 3y is equal to 18, which is represented in red color, and second line is 3x plus 3y is equal to 21 and it is represented in blue color. We have to determine this point 3 4. How we are getting a 3 and 4? So what was the formula that we used? X is given by C1B2 minus C2B1 upon A1B2 minus A2B1, and Y is equal to A1C2 minus A2C1 upon A1B2 minus A2B1. So in first step, write down values of A1, B1 and C1. A1 is equal to 2, B1 is equal to 3, C1 is equal to 18. A2 is equal to 3, B2 is equal to 3 and C2 is equal to 21. So this corresponds to these values A1, B1, C1, and for A2, B2, C2 this equation you can refer. So value of A2 is 3, value of B2 is 3, value of C2 is 21. Value of A1 is 2, value of B1 is 3 and value of C1 is 18. In next step, you simply have to substitute these values in this formula and do the calculations. So on substituting these values of A1, B1, C1 and A2, B2, C2, you can find that value of X comes as 3 and value of Y comes as 4. So it means that 3, 4 is the intersection point. Geometrically, it is possible to verify this. So this is point 3 and this is point 4. So point 3 and point 4 we get, that is intersection point has coordinates 3 and 4. Now let us come back to the linear programming problem. So just now we have seen how the value is 3 4, this point. In this way we have obtained all four vertices. So that completes the third step. Now fourth step is to determine value of objective function at vertices of common feasible region. At vertices of feasible region or common feasible region. Common means it is common to all linear and non-negativity constraints. So what is objective function here? Objective function is z is equal to 10x plus 20y, and we have four vertices. First vertex is say 0 0 and we will determine its value at point 0 0. So z is equal to, in this case, 10 into 0 plus 20 into 0, so 0 plus 0, and that equals to 0. Next vertex is say 7 0 and its value at point 70 is z is equal to 10 into 7, that is 70, plus 20 into 0, that is 0. 70 plus 0 equals to 70. Then at point 06 we will find the value. So at point 06 the value is z is equal to 10 into 0, that is 0, plus 6 into 20. Here we are substituting x as 0 and y as 6. So 10 into 0 plus 20 into 6, that is 120. So that is equal to 120. And at this point, so this was the value at 0, 6. Now finally, we'll determine the value at point 34. At point 34, the value is z is equal to, substitute x as 3, 10 into 3, 30, plus substitute y as 4, 20 into 4, 80. So 80 plus 30 is 110. So here the value at point 34 is 110. Recall that problem is of maximization. It is of maximization. So out of these four values, 110, 120, 70 and 0, which is the maximum value? The maximum value is 120, and thus the final solution of LPP is that objective function, so objective function z is equal to 10x plus 20y has maximum value, has maximum value. What is maximum value? We have identified maximum value is 120, as you can see here. Maximum value 120 at the point, it has got the maximum value. At which point it has the maximum value? At the point 0.6. At the point 0.6. So the final answer is that the objective function z is equal to 10x plus 20y has maximum value 120 at the point 0.6. This completes the solution of linear programming problem. I request you to solve some more examples on your own. Thank you.